So these are reconstructions, all based on material from Antarctica or southern Australia. And remember, southern Australia was about the same position as Antarctica and connected to it at the time. So here you're seeing diverse terrestrial animal communities, dinosaurs in this case, based on the age of the material, plants, all kinds of stuff. There's still probably a bit of snow, and it would still be dark for quite a few months of the year, but it was very different than it is today. But I mean, don't take my word for these reconstructions. I'll show you some actual examples of the material. So here, from Alexander Island, British Antarctic Survey found these fossils, lots of plants. Top right is a carnivorous dinosaur jaw. Bottom left is a vertebra from a large terrestrial carnivore found in the middle of Antarctica, and it looked like this. It's called Cryolophosaurus. And so an important thing here, I mean, it's a big dinosaur, it's neat, but to take away from it is that if this thing could live there, not only would it have to be fairly warm, but it also would have to be eating something, because I can't really imagine him, you know, jumping in the ocean to go grab some krill, right? And so what was he eating? Well, that's what the next picture in the bottom right is showing. These are teeth from a herbivorous dinosaur, a hadrosaur, or a duckbill. You may have seen them up in the fossil gallery upstairs. So guys like this. And so they're pretty large animals as well. We're talking something, you know, the size of like anywhere from a really big, like bigger than a moose to like the size of an elephant or more, depending on the species. Sometimes much larger. So they, again, need lots of food, and they eat plants, so lots of plants had to be growing. And here, this is from the same sort of time period in Antarctica, but this is representing the ocean. So what was around then? Well, the top is showing a skull of a marine reptile called a mosasaur. In the bottom, these are shark teeth, so everything was a diverse ecosystem. And this is a reconstruction of what a mosasaur looks like. So he's kind of a rough customer. And I mean, you wouldn't want to be swimming with him, he'd swallow you whole. But this brings us to what the island Claudia was talking about, Seymour Island. This was the big stop we wanted to go to, because this is where a lot of these fossils are coming from. And it's also where there's very important strata, so geological layers, that we can find. And why they're important, we'll get to in a second. But this is just a quick shot. So you can see on this trip, we didn't take any samples with us. We don't have permits, so everything has to be left as it is. No real interference, as best as we can. But as you can see, we did leave lots of footprints. Nice little trail along there. It's something we see a lot of down there on this island are fossilized trees. So this is, you can see the rings. And you'd find this all over the place, really well preserved. So obviously there was a lot of really healthy plants growing here. And these materials are close to 65 million years old, so quite a ways back. But what is the KD boundary? Well, it's the time between the Cretaceous period, from the age of the dinosaurs, and it's where that ends in the next period, the Tertiary, and then into the Cenozoic, which is known as the age of mammals, when that starts. And why is this changeover? Well, there was a large asteroid impact that we know from data from Mexico and from other data across the world. Something struck about 65 million years ago and caused a massive cataclysmic extinction. So you had your dinosaurs just minding their own business, sort of on top, mammals, you know, doing their own thing, scurrying around. And one day, this happens. And now, no more dinosaurs. And we can joke about that, but if you think of the kind of scale of death and destruction from this, the asteroid, I think, was something like 15 kilometers long. And when it struck, the energy released is comparable, I think, like some ridiculous number, like billions of nuclear weapons or something. So we're talking about something that is the second largest mass extinction in Earth's history and is thought to have wiped out about 70% of life on the planet. So a pretty serious thing in just like a brief flash of time. And so what is that crazy, this extreme event, what does it look like in the rock? Well, it's right there. Can you see it? Well, it's not, seeing it in the rock is not quite as exciting as the actual event, I'm sure, but at least you don't have to be vaporized because of it. So here's a geologic timescale. Cretaceous, the top of the green, and then right above it, the Paleogene, which is the new name for the Tertiary. So that's 65 million years ago. And by looking at rock layers we could see here, based on prior research done, we could identify several layers of this green marine clay called glauconite, which is in the rock there in the sediment. And the boundary, which is detected by a spike in a chemical called iridium, which you can't see, but they can detect with when they scan for it, they have to collect it. Well, that previous research has been done, and they say it's right above these two layers of this glauconite beds. So we see them there, and then just above them, that's about where the boundary is. And what do we find around that boundary? Well, aside from just sort of sandy deposit, you see this. And hopefully it turns out it looks a bit better on my screen, but this is burnt wood. This is charcoal, and it's about 65 million years old. So what's this showing? This is related to that impact. You have this massive release of energy, release of heat, and it's causing global wildfires. And we find sites like this in about 20 locations in the world, and many of them have this charcoal bed all at the exact same time. And it's correlated really well with the sudden disappearance of these major animal groups. But this sort of massive wipeout, surely this obliterated everything on Antarctica, and that's why it's like what it is today. Well, not really. Very soon after the extinction, life comes back, and it comes back sort of with fury. And so you see the dinosaurs are gone, but they've been replaced. Now the big thing is mammals, as well as some birds, which are their descendants, the dinosaurs. So even though we have this extreme event, life finds a way. So really the question is, if that didn't totally change the ecosystem over from this sort of thing that we would see in the past in the fossil record, this diverse terrestrial ecosystem where there's diverse plant communities, large herbivores, carnivores, if that didn't do it, if that didn't cause this change to this sort of far less diverse marine-dominated ecosystem where these extremely adapted creatures eke out an existence on otherwise barren land, then what did? Well, that's an extremely big question, and it's a very long question. And that's actually what's going to be covered. That sort of changeover, these long-term changes that cause this, is what we're going to address in the next few talks. So, thank you.